So let's start off with a simple unit test. This sort of test will form the backbone of your automated testing because it's so focused on one specific thing. And in this example, we're going to test this class here, this profit loss calculator, specifically this method, or well, this is the only method that I have. I want to validate that this thing is doing what it's supposed to do. So let's take a look at the inputs. We have a list of trades. We call it the closed trades. That means that there's some condition here. But if for some reason a trade isn't closed, I'll just skip that one. Then keep a running tally of the total profit loss here, which is calculated by taking the close price minus the open price. So the price that I sold it at minus the price that I bought it at, and that gives me the profit or loss. And then I return a double value to denote that profit or loss. So we're going to unit test this piece of functionality. In order to do that, we need some dependencies. Now, if you created this project with IntelliJ, it'll generate this code with the project. But in case you don't have this, we have this org JUnit, JUnit BOM, and this is test implementation. And then we have this platform here. Next up is going to be a test implementation on a JUnit Jupyter. And then we have a test runtime only for this JUnit platform. And we need this to actually start and run our tests. That's it for the dependencies on very simple unit tests. To actually make one, let's go to our test directory here. So in our source, we have main and test. I'll go to the test and then create a new package here. And to make things easy, I'm going to copy the package from this class I want to test and simply put it in here. Now we have a test class that's in the same package as the one that we're testing. And for that, I'll create a new class. And by convention, we call these test classes the same thing as the class that we're testing with this word appended to the end. That's just a convention. Let's see how to make a basic unit test. I'll start with this test annotation. And this is coming from this JUnit Jupyter dependency that we added. I guess it's useful to quickly take a look at how this stuff works. So just test something. Usually these unit tests, they follow this sort of pattern. It's the AAA approach to this. The first A stands for arrange. And in this step, we set up test data, the expected outputs that we expect to receive from this based on the test data. And this is the input. So maybe it'd be better to call it the setup test input data, and then also the class to test. So let's do that. In our case, we have a list of trades. This is going to be our test closed trades. I'll initialize this to a new linked list, and then I'll add some trades to it. Let's see here, test closed trades.add. A new trade. What do we need here? A whole bunch of stuff. Now it's important to go and take a look at what our method needs. It's pretty much only the close price and is open. So we'll say is open is going to be false, and then we need to set up this close price and open price. So for that, I can actually do something like this. I'll have a private method in here to create one of these test trades. The open price and close price need to be passed in as arguments so that I can set those, I can control those directly. But all the rest of those parameters, everything else in here, there's ID, instrument, all this stuff, I don't need that information, so they can be whatever data. So I'll just simply return a new trade here for the trade ID. I'll have a random UUID. The instrument doesn't really matter, but we can go with something that exists. So this is a pretty popular Forex pair. The open price, that was a parameter we passed in. The open time also doesn't matter. Local date time.now is fine. The close time is also the same thing, so it doesn't matter. All that matters is that we set up the close price, and then is open will be false. The account ID, same thing. I'll just random this value here. Now it's pretty easy to set up new trades here. Let's say we opened the trade at 1.0 and we closed it at 1.1. That would mean we have an expected profit of 0.1 because we take the close price, the one we sold it at, minus the price that we bought it at, and gives us our profit there. Okay, so now that we have our test data and our expected output, we still need the class to test. And by convention, we call this thing the system under test, or SUT for short. And this is going to be a new profit loss calculator. And that does it for our arrange step in here. The next A stands for action. And this is where we perform the operation to get the actual result. And for that, I'll have a double value. That's the output of this method. I'll call this my actual. Then I'll say sut.calculate and pass in my test close trades. So this is going to run through this code and then perform the operation. And that's pretty much it for the action. The last one is to assert. So this is where we validate the result. And we have a grade package for this, or a grade class. It's also from this Jupyter dependency. It's known as assertions. This is a static class or a utility class somewhere. It has a whole bunch of methods on there. They all start with assert, and we use this during our test. So in this case, we have an expected profit and we have the actual one. So we want to assert that these two values are equals. And we start with the expected one. So by convention, the expected is first. So I'll put in the expected profit there, and then the actual profit here. And that's it. Let's run this test. Just in here in the IDE here, clicking on this green arrow thing here, and then we can run it. And this should do the trick. So there we go. We've run this test. Now let me show you what's great about this. Let's say somewhere in the future I make some changes here, but I make a mistake. I say it's actually the open price minus the closing price, and that's going to give me my profit and loss. So now if I run this test, it's telling me that it failed, and it says here that the expected was 1 or 0.1, but the actual is negative 0.1. So now I know that there's a problem already. And if I really don't know what's going on, I can add breakpoints here. So if I add a breakpoint there and debug this unit test inside the IDE, that's a great way to see what's actually going wrong. So I can just step through this code. We have our total profit loss, that's correct. The test closed trades coming in, these are also fine. We have an open price and a closed price. Then I step through it. That's not going to happen. I see here total profit loss is going to be T.open price minus the close price. And now I already know what the problem is. But I found out what the problem was, and it's because of this change that I made. So thanks to my unit test, I caught that bug before it actually was deployed and used by anyone. So that's it. Let's take a quick summary. We have here the AAA for our unit test. This is a very simple unit test. We only need those dependencies that were added by the IDE when I created this project. And we have here the arrange step. This is where we set up the class to test. We call that the system under test. And this makes it easy to just at a glance see what this test is all about. We have some test data and the expected output. Then we do the action. We perform that, we call that method to test. Then make assertions.